Hello, am I audible?
Yes.
Okay, okay, again we resume our session. I hope everyone having a replacement lunch. Okay, Mr. Milan, having a replacement
Okay.
lunch.
Yeah. Thank you. Yeah, hello, everyone. So we resume now from where we have left off. So let me just share my screen. Give me a minute. Uh, Kinjal ma'am, can you allow screen sharing to me? Uh, who's the host here? I need permission for screen sharing. If someone can provide me. Kantav sir. Just a minute, guys.
Hello. Now it is okay.
Let me try. Okay, yeah, that is fine.
Okay.
Okay, I hope my screen is visible now. So last we discussed importing modules. So basically, now where we are at is we have covered the function. We have covered how to um, import external functions. Maybe it is not uh, directly as a part of Python inbuilt function. Okay? So now there are two important function that we need to cover. So which I will put it as a utility function. So which are the very common function that Python developers use, right? And after that, we will cover certain points, and then we will focus on practicing on what we have learned, right? So basically, collaborative session. In that. So let's start with map function, right? So what map function does is you give that function, you give a map function a function which will apply to each item in an iterable meaning it can be list, it can be dict, it can be set, anything, right? And then it will return a map object, right, which you need to convert it to list and tuple. So you cannot directly print it. That is the major gotcha here. Okay, so the syntax is, we have a map, you give it a function, and you give it a iterable. So function is anything, any function, maybe it is a built-in function, maybe it is a user defined function that you have written, or it can be lambda function. So lambda function also, we will see what it is. Then iterable, as I mentioned, list, tuple, anything. So one important thing, as I mentioned, it will return you an map object. It will not return you a object that you can print. Even if you try to print output of map function, it will not make any sense, right? So what you have to do is, you have to use other converter function like list, dict, or other function to convert it into, again, iterable, and then use it, right? So that's very important. Then if you want to transform data, right, this will be used. You can do the same thing with the loop as well, but again, it is easy to read, right, and easy to use. So let's see one example of how a map function looks like. So over here, here we have an example. Here we are defining a function called double. So definition double, it is accepting one argument, that is x, and what we are doing is, whatever argument is passed, we are multiplying it by 2 and returning it back. All right, so that is our user defined function. Now over here we have a list of number, so between 1 to 5, a static integer array we have defined. Now what we do is doubled number underscore map, right? This is the variable we have defined, and we are calling a map function. In that, what we are passing is, we are passing this double. This is the user defined function, and number. So number is 1 2 3 4 5. So now what it will map method will do is, it will take one number, and it will call this double function 5 times, right? And what it will create, a basically a map of this object, right, which can be used to then to be converted and later to be used. So what will happen is, it will the object will be stored in map variable, and then you convert it to a list object, right? So double number list. So original number we will print, and then doubled numbers using map, that we will print. So original number is 1 2 3 4 5, and the double number using map is 2 4 6 8 and 10. So this is how the map will work. So to give you guys an example, right, what I mean, let's go to an example. Let's take this example. Okay, so here, similar to what we have seen, we have names, Alice and Bob, and what we are doing is, we are capitalizing the list, calling a map string dot capitalize and names. So capitalize is a method on string, right? So let's just run this first. Okay, so what it has given is, first letter of a word converted to capital. Now let's break this down to, let's say, capitalized map. So instead of converting it to list, we do this and this. Basically, we are doing this into 3 steps. Same output, right? Now let's say, rather than converting this into list, we just what we do is we print this directly. Okay, what we do is we print capitalized map and see what happens. Okay, so what it will print is map object as what it looks like is some memory location, right? So if you go try printing this output of a map, it will not work. What you have to do is you have to convert it into a list and then use it. Okay, so what map helps us is with taking any items in an iterable and applying certain operations, right? Which are very common. Now let's take another example of map. Okay, so here we have another list of name, and over here what we have used is something called lambda. So lambda is a function, right? It will take one name as an input, okay, and it will apply certain operation. So you, if you want to write a function in line, right? Instead of defining a function over here, if you want to define a small function in line, right, which with very short content and it get executed on that particular scope only, then you use a something called a lambda function. Okay, so for that you use a keyword lambda, uh, give one name, basically the argument name, and then uh, after colon what you can do is you can perform your operation, right? So over here we have defined lambda, give argument a name dot capitalize is the operation we are doing, and we are to map function we are passing a second argument, that is names, right? So it will take name Alice, pass it to lambda function, capitalize it, basically converting first letter to capital. Then it will take Bob, pass it to the name, capitalize it, and so on. So this is how you can use lambda function. Now let's say you want to do lambda function for sum, right? Or maybe lambda function for uppercase, right? You just put a name and perform your operation. Then again we are converting to list string, straightforward process. We are using formatted string with f, original names, and then capitalized name. So what it will do is it will return us the capitalized version of our list. So as you can see, it is a very powerful thing. Rather than writing multiple for loops, if your operations are straightforward, you can easily do that with map, and those are much more faster in execution as well. Okay, so let's just once see another lambda function in action. So here we have numbers 1 2 3. Over here we are defining a lambda function called and passing an argument as x. What we are doing is we are doing x into 2, multiplying anything that we received into 2. So over here we are converting it to list and then printing. Okay, so 2 4 6. So I hope you guys got to know what lambda functions are. So if you want to try, I will give you guys some time so you can try it once, right? Rather than let's say multiplication, you can do plus also, right? Or any operation that you wish to. Yeah. So I will bring this, keep this syntax in the screen. If you want to follow along, you can do that, and then we will move forward to another function. Okay. Now next is filter function. So this function is also one of the commonly used function, especially when you are working with remote APIs, right? Let's say someone is working in a project in which you are calling some API. Now, that API returns you some list of results. So, with those results, if you want to iterate over it, filter out certain data, right, you will most likely using either map or filter function, right? So, filter function, uh, again, similar syntax. What it differs is it is if the particular condition is met, then it will include or exclude that particular iterable item from the list, from the result basically. So what it will do is it will return a list or tuple, unlike a map, which you can directly use. So you have a filter, and you need to pass a function. So now what you have to make sure is this function that you write, it returns either true or false. Why? Because based on the outcome of this function, filter will consider whether to use this item or send this item further or not. And second is iterable. So iterable is either list, tuple, set, dictionary, anything. Okay? Now we can combine this filter with a map also if you want to do any complex operation, right? Which we can see later. So here is an example of filter, right? So here we have a number 125, and over here what we are doing is same old our logical program of finding even number or odd number, right? So here what we are doing is we are, first of all, let's go from here. We have a filter function. First argument is a function to be passed, so that should return us true or false. So here what we have done is we have used lambda function. Lambda function is basically function without a name, right? So there we are passing one argument x. Now what we are checking is if x mod 2 is equal 0. Basically, if it is divided by 2, that means it is an even number, right? So since this is a condition, right, x mod is a condition operator, sorry, equal to is a conditional operator, and mode is to get the reminder of this, right? So it will return either true or false. So this expression will evaluate, and either it will return true or false. Over here we have numbers, so we will pick one number, right? It will be passed on to lambda function, like 1 divide 1 mod 2 is 0, no. 2 mod 2 0, yes. 3, no. 4 mod 2 is equal to 0, yes, right? So like that we have two true value received. So what filter will do is those two true values, right, it will pass on as a result. So in this case we are converting into list, right? And then we are printing, so output will be 2 and 4. Okay. I hope that is clear. Take a look at it. You will be able to understand it now that we have seen a couple of example of it. Now second example that we have is a user defined function, so similar to what we have done for map. For filter, we are writing a function that is positive, and if it is a positive number, right, then we are returning true or false. So basically if n is greater than 0, so this is a conditional operator. So either it will return true or false. So what will happen over here is we will receive a number, and after the result is evaluated, true or false is passed. And over here in filter, we are using the is positive. So remember that we are not passing this as a with a curly braces, right? We are just passing this as a name of the function, which is positive. If you are passing with curly braces, that means you are doing function execution, which is something that we are not doing. We are passing a object of it, right? Filter is positive, first argument. Second argument, we have, instead of creating variable, we are passing an array directly. So first argument function, second argument is iterable. In this case, we have a list. So again, same thing. It will pass -2 to this is positive function. -2 is greater than 0. No. -1. No. 0 is greater than 0. No. 1 is greater than 0. Yes. So it will print 1 and 2. Okay. So let's look at this in Colab and try it out once. Okay. Here is our example of even number 2 and 4. Okay. Now here we have another example in which, let's say you have a requirement in which if you have a word that is, you want to find out the word which are less than 4 characters, right? So you can do that easily with this. So what you do is you do filter, you pass an argument w, you do the length, you check the length whether the particular word has how many number of characters, so with, and whether it is less than 4, right? So let's try this out, right? That is dog, and at apple is almost I think 4 5 characters, right? So that is not part of this. Okay. So let's look at len also, how works. If let's say if we want to see length of words of 0, right? So first one, apple, it is 5. So here we see that the len function, if you apply it to the strings, it will return you the length of the string. Okay. Now another similar concept while iterating over a list, right, is enumeration. So what enumeration means is if you want to get the index of any particular item, then you can use enumerate. Okay. So how it will work is you pass, let's say you have a array of strings, red, green, blue. Then what you do is you use different syntax for loop, that is index and color, right? In enumerate is a you can consider it as a function and pass an array. So this one does not have index included right now, right? But what enumerate will do is it will create a index key also, and it will pass to index and color to actual value to color. So this is a key and this is a value, right? And we are printing index and color. So here we see 0 1 2, and these are the index. If I had, let's say, another color, so it will be 3 and yellow. So this is how, in case during your program, if you need to access index also, you can do this with enumerate. Okay? So I will give a few seconds to review this, and then we will move on. Okay. Now let's look at another method that may be handy if you need to uh, use it. The method is called zip, right? So it will be used to combine two lists. Let's say in one list you have a list of people name, and in another list you have a scoring of those particular members. So what you can do is you can use a zip function, pass it the first name of an list, second argument, second list, right? And what it will do is it will combine first items and put it into another list. Just let me run this. So over here we have a Alice, score is 85, Bob, score is 90, Nathan, score is 80, right? So if your operation involves combining relevant items of the two list, you can use this function. Okay. Okay. Now let's go to another topic, which is class and method. So class we will look at in detail in for the practical terms. But if you want to create a class in Python, you use the keyword class. So class is basically a blueprint for creating objects, similar to maybe in C++ or Java you might have tried, right? So similar to that, you create a class, okay? And in class, you can define attributes, which is data, method, which are functions. So these attributes and method can be either private or public, right? So how you create a class is class colon class name. Um, it is always a best practice to put first character of a name as a capital, right? And then what you see here, def underscore underscore init underscore underscore self and name. This is what is called constructor in Python. So if you want to create a class and you want to call a constructor on it, you will use underscore underscore init underscore underscore method syntax. Now here you are seeing two arguments. So first one is self. So self argument is implicitly passed on by Python, right, to all the classes. If you call any class, right, let's say let's say for constructor, it will implicitly pass to you. It implicitly pass you the self meaning the object of class itself, the reference of class itself, in this case a person. And then second argument is the user defined argument, which is passed by user. This can be anything, right? So here what we are doing is self dot name equal to name. So what we have done here essentially is we have created a private variable called name. So this variable you cannot access it directly via object. Okay? So we have assigned it a value, basically initialize it, which is what constructors are supposed to do. And over here we have written a method, class method, that is greet. Again, self is implicitly passed, right? And then what we are doing is we are returning formatted string, hi, I am self dot name. Self is a class object. So what it will do is it will return self dot name, that is private variable, because as this is a private variable we cannot access it via object name. Okay, so that is why some sort of getter method is needed. Now another concept, how do you create a object of the class? So simply, there are no keywords needs to be used here, similar to how we are doing variable declaration. What we do is we just give it a name, p1 equal to person, and we are passing a name of a person. So basically the second argument you see over here, it is passed on to the constructor. So essentially we are passing an argument to constructor here. Now what we do is we call a p1 dot greet. So we are calling a greet method of this class, and it will return us a formatted string. So we have set up this private variable which will be returned to us. So the output will be hi, I am Milan. Okay, so this is how you create a class in Python. Okay? So I will give you guys a minute. Just go over this syntax. Keep this in mind so that we can look at additional example of this. There are many operations we can perform with the class, but this is just a what basic class syntax looks like. Okay, so now let's go to some of the practical examples. Okay, so this is the same program that we have seen in the example. So here, let's execute it. Okay, hello, my name is Alice. So now let's try few things here, right? Let's say I want to access or I want to print p dot name. Okay, let's try that. Okay, my name is Alice. Okay, now let's take example of another. Let's say we have a class circle, and that what we are doing is we are initializing a constructor. Self is the internal object radius we are passing, self dot radius equal to radius. We are performing the calculation, and we are again printing the results. Okay, so over here we are passing 5, which in turn assigns to it internal variable radius, right? And over here what it will do is it will perform the area calculation and return the results to us. Okay? Now let's look at example of class inheritance. So with class inheritance, what will happen is, let's say we have a class called animal. So animal, we define a behavior which is speak. Again, we pass a self. So by default, when you work with classes, you pass a self argument. It will be implicit. So speak self, it will return some sound. Okay? Then dog. Now, how do you inherit another class in Python? Is you pass an another argument, and that is a name of the parent class. So dog inherits animal. So now dog will have access to methods and variables of animal class. So we do def speak self again, and here we are specifying specific sound, which is, as it is dog, so it is bark. Okay? Again, we are creating another class, that is cat, right? So cat, what it will do is, it is again part of animal class, right? So it is the parent class is animal, so a cat belongs to animal type of classes, right? So over here we receive animal as an argument, which is a parent class of it, and again speak self meow. Okay, so now what we do is we created two objects, one for dog, another for cat. So when I invoke the function speak, what it will do is it will execute the function of, if you, since the speak is inside parent class also and speak is inside child class also, it will invoke the function of a child class, right? So a dot speak, the dog, for dog it is bark, for cat it is meow. Okay, if the class itself does not provide the implementation of that method, let's say we create a third class which does not have speak method, right? In that case, the parent class method will be called. Okay, so I hope you guys got the idea how inheritance works in Python. Okay, now another thing you can try with the class is inheritance with super method, right? So here let's say I have a class vehicle, okay, uh, on which what I'm doing is I'm creating a constructor self and brand. So vehicle will have one of the attribute, that is brand, right? And vehicle can move, right? So this is a base behavior for any vehicle. It can have a brand, it can have a, it can move, or we can define any number of attributes like engine number, chassis number, whatever we want to, like number of tires, things like that. So this method is move. Then what we are doing is we are returning self dot brand is moving. Okay. Then we have a car method, sorry, car class, on which we are which we are deriving from a parent class vehicle. So basically, car is a class of type vehicle as a parent, right? Class parent. So here, what will happen is def constructor method self brand and model. Okay. Now over here, what we are doing is this car method car class does not have a implicit variable of like brand, right? So brand, we want to make sure we set it for our parent class. So what we do is we call a super meaning for current class. What is the parent class? So we have only at a time in Python we will have only one parent class of any particular class. So we do super dot then underscore in it the name of this constructor, and then we pass a brand name, so which will in turn will be set as brand over here. Okay. Then self dot model equal to model, car model basically. So that is as a second argument. So over here you see the constructor is taking two arguments, right? So any number of argument you can pass to constructor. The only condition is self should be the first argument. Right? Now, after setting this, we are also creating one method called move. Basically, we are doing method overriding here. So then what will happen is move method will override the parent. Okay. So now what will happen is self dot brand and then self dot model. So as model is also available. So this is for us to explicitly call the constructor of superclass in case we need it, right? Access we can do self dot brand and self dot model drives on roads. So now if we run this, okay, Toyota Camry drives on roads, right? So Toyota first argument, that is brand, which is set for the parent class. Then Camry as also model drives on roads. Okay. So this is how we uh, access super class from a child class. Okay. I will give you guys a minute to just go through it, okay, and then we can move forward. Okay. Now there is something called static method in almost all object-oriented programming languages, right? So here in Python also we have a concept of class method and static method, right? So class method, what it does is it will take one parameter right? While static method will not. So class method is basically state aware, where static method is not, in simplest terms, right? So if you want to do any class specific operations, you can do that with class method, right? And static method is just a static method. You can just invoke it with class name, right? So over here, let's see, we have a math utils class defined. This we are defining as a class method, right? So that we can invoke it directly. We don't have to create a object. Okay? Then circle area, CLS, this class, then radius, right? Then here we have CLS dot pi. So pi we have already set up for this class as a 3.14. So since we are using a class method, what it will do is it can access the value of a class, any maybe constant or any maybe any value that is already statically, everything. Then we do radius into radius, right? Straightforward calculation. Then we have this example of static method as well. So what static method will do is it is a stateless. Basically, it does not know anything about anything. It is a utility method. You use it to perform certain calculation or perform some manipulation on any particular data, right? So here we are just passing a and b and we are just returning a sum. So here static method does not have any access or any usage of pi, because it does not have any access of this class variable. So that is the reason, right? Now let's just run it. Okay, so we have 78.53 and 5, right? Which is basically 2 plus 3 is 5. So over here we have class math utils dot circle area, this, and over here we are passing 5, that is the second argument. So notice here class similar to that self argument in constructor and other places, we have not passed it explicitly, but it is implicitly provided by Python, right? So this type of functionality you will see in many places in Python, right? So make sure whenever you are passing any first argument, see that if it is a class method, then it may receive implicit self class reference argument. Okay? So this is how we create class method and static method, and this one uh, right here with at the rate class method, this is how you specify that this is a class method. This is called a annotation. So during compilation time or when execution is going on, uh, apart from comment, this one is ignored but implicitly used to mark this method as a class or static method. Okay, okay, I will give you guys 1 minute if you want to follow this along. Otherwise, we can move with another example of the class. Now let's move forward with how to define a private attributes. So so far what we have done is when we do like self dot we give anything, right? It will be accessible with class object, but when we want to create a private variable, right, that will not be accessible with the class object. So how you do that is, what you do is you do self dot double underscore, and then you do name of the variable, right, and then you pass a balance or whatever the assignment you want to do. So over here we have a bank account underscore underscore init. Then we have one method called deposit, right? And again we are passing self, that is an implicit object of class amount, get balance, again self, and self dot balance. Let's first execute this and then see. Okay? So 1500. Now let's try ACC dot balance. Let's try to print this. Will it work? No. Account object has no attribute balance. Okay. Now let's try account underscore underscore balance. Right. Again, bank account object has no attribute on balance. Why? Because with Python, anything that is there with underscore underscore is considered as a special. Like here we have a underscore underscore minute init method, which is treated as a constructor. Here we have double underscore and then variable name, right, which is considered as a private, right? So you will not be able to access the balance variable outside the class or by using the object. Now to do that, what we do is generally for any private variables, if you want to set the variable or you want to get the variable, we create what is called getters and setter, right? So here is an example of getter. So what it will do is it will do, you do get balance simply, and what it will do is self dot underscore underscore balance, and then it will return this value of this variable to you. Now even if you want to set a balance, so this is a, you can do set underscore balance also, but since in terms of balance, generally you do deposit or withdrawal, right? So you do methods like that. But if you have a variable which you just want to directly set, then you need to what you can create what is called setter. So basically it will set the value of that. Now why we have to create getters and setter is because to avoid any accidental changes to your data while you are working. Now, let's say there is a, you are working with a team, right? And then uh, you have one important variable, for example balance, right? This balance should not be used lightly, right? So you mark it as a private, right? So one level of protection you have there, that nobody will directly access it via object and make any manipulation with it, right? So that is one. Second thing how you protect is, as you create a getter and setter. So in terms of setter, what you do is, you to setter you have to pass an argument. If you want to change the value, you it has to go through via setter, and that you can put certain conditions, and if those conditions does not met, you can reject that update. So for example, balance should not be 0 or less than 0, right? Or balance, or the value that you are setting, it should be integer, it should not be string. So if any other developer comes in and misunderstood certain variable that you have created, So at that point, you have a way of protecting the consistency or integrity of your variable, right? So you can put two level of checks over here, right? So apart from just setting it private, these two things are important. Now let me just remove it and run it. Okay. Okay. So I'll give you guys a minute. Go through it if you want, or follow it along, and then we can move forward. Okay. Now let's look at another example, that is operator overloading. So I think in C++ and other languages, you should have seen the operator overloading, how it is done. So Python also provides something similar, right? Generally, it is not been used widely, but for the sake of just knowing that okay, this is what is exists. So let's go through this as well. Okay, class. Here we are defining a class point, right? And what we are doing is we are to the constructor we are passing x and y, right? Self is implicit, x and y of the point. So this is the coordinates of one particular point. Now what we are doing is we are using a special, again, special syntax of double underscore add double underscore. So now what this will do is this will override a plus operator for this particular class. So first argument, as always, self. Second argument is what you want to pass to this operator overloading. In this case, since we are going to do addition of 2 point classes, it will be other point class, right? One will be self, another one will be second second class, right? So over here, what we do is we return point self.x plus other.x, right? And then self.y and other.y, right? So self is the first class, other is a second class, right? And then we have a str method. So str method also we are overriding. Basically, if you want to print it, right, what you do is you again pass self.x and self.y, right? So here we have p1 point 1 and 2. We are initializing x and y of point 1. Here we have another point 2, that is 3 and 4. Now what here we are doing is we are doing addition. So it will call underscore underscore add underscore underscore. So it will do the addition, and then it will return the result. But now print, what it will do is print will implicitly call underscore underscore str, right? So now let's run it, right? So here you see 4 and 6. So now if you override this str method, then you will be able to get a good output of the class if you pass, right? So this is in turn you have passed point object, right? Now let's try print p1, okay, and print p2, okay. Why? Because you are able to see this output. Why? Because you have overridden this str method. Now if you comment this one out, see, you will not be able to get the output, because print has tried to print the class object, but it will not be able to print string representation of it, right? So that is why if you override str method, you will be able to see the proper output of things, okay. Go to, okay, I hope that is clear. Just take a look at it, understand it, and then we will move forward. Okay, uh, now let's move on to another concept. This I think we have cleared earlier in for private method example, but here is how you create a getter and setter, right? So as I have explained earlier, so here you have a student, okay. um, Student, we have a constructor class self name and grade. We are assigning as a private variables, okay. Next what we are doing is we are creating a getter method that is get grade, which is returning grade of the student. Then important method that is set, right? So set grade self and value. So as I have mentioned earlier, you can put a validations to the value you are setting to your variable. So if grade variable, if it is valid, meaning if the value is less than or equal to 100 and greater than 0, then only you will accept it. Okay, self dot grade equal to value. Otherwise, what you will do is you will reject the update. Basically, you will print that invalid grade. Right? So that way you are protecting your important data. So you are calling get grade, doing set grade, again you are doing get grade. Okay. Okay, now let's say if I'm passing invalid grade. Okay, let's say by mistake I have mistyped it to 950. Now let's see. Okay, it has printed invalid grade, and my grade remains same, that is 95, which was set earlier. Okay. Okay. So with that, we close the concept of classes and methods. I hope you guys have got the good understanding of how to write classes, how to write methods, because these are very essential to what you are going to work on if you decide to use Python for your projects or in the industry, right? So practice this, right? And next we will move forward to some of the other concept, like some of the things I think you guys should know. Okay, so here is an example of a nested loop. We have gone through the loop, but here is just an example of some common problems that you encounter, like in terms of logical programs, right? There is a program of matrix traverse, right? So how you do the matrix traverse? So let's say you have a matrix 1 2 3 4 5 6 7 8 9. Now that matrix, you what you do is you create a first for loop, and then you create an inner for loop. So row in matrix, that is this, and then after this, notice that this is a sub list, right? This is the list one, and this is the list sub list. Then what we'll do is row in val, print val, and end equal to space, right? So in print, by default, if you use print once, the next line character will be appended, right, or added. So to prevent that and to print matrix, we are saying end equal to space, right? So here, why I have put end, because in print syntax there are multiple arguments print is accepting, and out of that what I want to pass is end, right? Because there are 4 5 other variable arguments we have seen. So out of that I want to pass end argument, and that should be space, right? So what it will do is it will not do next line, but while it is printing this matrix, it will give space. And then once this for loop is over, basically the scope, and notice the indentation. So this print statement is over. Now I am here writing another print statement, right? So since this is out of this indent, this will be considered out of this for scope, right? And when I'm passing empty print, it will just do empty slash n. So again it will take second list and then third list, right? Now let's run it. Okay. Yeah. So it has printed the matrix. Once it is gone out of the loop, it has printed new line here. Now in case if I remove this end, it will print everything in new line, which is what we want to avoid. Okay. Okay. Now another common program sometimes which is asked is creating a pattern with numbers, right? So over here, let's look at the pattern first to get a proper idea. Okay? So this type of pattern, if you want to create, so what you will do is, let's say you will create define n equal to 4, right? Then 4 I in range, so whatever logic that you want to give, right? So range, as we have seen, is a function. So here what we are doing is we have two arguments to range. First one is start, meaning we want to start with 1. If we don't do that, then it will start with 0. And then n plus 1, meaning second argument, also we have seen, right? If we put 4, then it will go till 3. Yeah, it is excluding the end, right? So to include the end, what we are doing is we are doing n plus 1. Okay. And then similarly in J range 1 and I plus 1, right? And then print J and n equal to space. Okay. So take a look at this two example. This may be handy in terms of any logical programs that has been asked to do. So you should know how to use this. Okay. Okay. Now, last example that we will cover is chaining of comparison operator. Right. So over here, so far, what example we have seen was consisting of only one operation, right? Uh, Either it is something is equal to 0, something is less than this, something is less than that. But now if you want to apply and or conditions, how do you do that, right? In Generally in if condition you may have a multiple conditions to check, right? In if else, so how do you do that? You do that with and or, right? So for example, over here I have x equal to 15. So let's say I want to check whether the x is greater than 10 and x is less than 20, right? So if that is there, then this should return true, right? And since this is a conditional operator, it will always return true and false, right? So similar to what we have seen for lambda functions, right? So let's try it first. Now, similar thing you can try with the short notation also, like x is greater than 10 and x is less than 20, right? So this is also again true, right? But this will make it little difficult to read, right? But this is something you can also try. Now over here we have a second example, right? Same like this, but a little differently tried. So here we have x equal to 7. We do print, and here we are using not operator. So if you have a question like how do I do negative condition, right? If my outcome is true, then I want to make it false, right? So in that case, you can use not operator or or keyword basically. So print. So 5 is less than x and x is less than 10, right? So this is what it is equivalent to. Okay. So if x is greater than 5 and if x is less than 10, okay. So let's run it. This false. Okay. Okay. Take a minute and look at it. So you will get an idea how to write the conditions. Okay, all right. I think we are done with this. Okay, so now we are done with class and methods. Okay, now we will take few minutes and understand some of the concepts which you will encounter when you are learning Python. Okay, so first one is virtual environments. So what is virtual environment? So the purpose of virtual environment is to isolate Python project to manage dependencies and avoid conflicts. So what I mean by this is when you work with Python, right? When you start working with multiple project basically in Python, right? At that time, what will happen is you will encounter issue in which code that is working in one machine, right? Maybe your colleague's machine may not work in your machine. Why? Because of you and your colleague may have a different version of Python, right? The colleague may be using Python 3.10, you may be using Python 3.11, or there are other packages, right, that you are using. As we have seen earlier, right, there are another framework like Django, Flask. So with that, you may have to use different libraries of Python. So now those library may have a different version as well, right? So what will end up happening is you may spend time debugging error, right, which is just caused by you and your colleague using different Python version. Or if it is not two-person, then maybe you are working on two different projects. One you have started working 2 years earlier. Now you have not changed any version or things like that, so you have to work with version that was released 2 years back. Now today, if you are starting a project, you will not want to work with the same Python version or same old libraries. So what do you do? Right. So in that case, the virtual environment comes handy. Right. It is similar to how you spin up virtual machine VMs. Right. It has everything fresh. So in V, so now with virtual machine, what you can do is you can create a separate sandboxed environment which is separate than another environment. So you can give that environment a name. Let's say sandbox 1. In that you install Python, whatever version you want. You install other libraries that you want to install it, right? Let's say math libraries, pandas. uh, you will encounter many more libraries, right? TensorFlow you may want to install. So whatever the installation you do, that will be remain only that environment, on that environment only, and that environment will only work when you activate that environment. So till the time you are in that environment, you can work with old version of maybe Python or new version of Python, whatever it is, but your libraries will be staying consistent, right? So your code will work. So that's how you solve the problem of code working in one developer's machine, not working in another ones because of the version mismatch. Now, another advantage of this is you don't have to change things globally. Like let's say if you have to upgrade the Python version, you don't have to upgrade it globally, right? OS level. You can still have your Python 3.11 at OS level that OS has given you, but you can have another version of Python for the project that you are working on. Okay. So now to how do you do that, right? So there are two popular tools which are widely used by developers. First one is virtual environment called VENV. It is a built-in Python module, right? Python package itself. And there is another called Anaconda, which is more advanced, right? And it is environment and package manager, right? So at the left hand side, we have a example of VENV. So how it is easy to create a virtual environment. So with Python 3.3 and plus, you get it by default, right? Otherwise, you have to just do some run additional command to pip install virtual environment or something like that, right? Which you can find on the internet. So once you have that installed, VENV installed, what you do is you do Python dash m virtual environment and VENV and name of the environment that you want to create, right? Now, depending on the which OS you are in, right? What you can do is you can do source my virtual environment, the name of the environment you have created, bin and activate. Right? If you are on Windows, it is different. If you are on Linux, you can use source command, right? Like like just I did. And if you are in Windows, then you have to use something like this my script. So my is the folder that will be created, and everything that you install will be available inside that folder only. So that way you sandbox your environment. Next, what you do is we have a command called pip. Like, we will cover it after this slide. But what pip essentially does is it will install another packages, and in this case, the package name is requests. right? So pip install request. So this package, it will be installed inside your folder, right? once it is Once you are done with using pip, then what you can do is you can just type deactivate, sorry, not pip, but virtual environment, and you can just type deactivate, which is a command available inside this scripts or bin, which will get you out of the environment that you are working on. Okay? So virtual environment VENV is ideal for like lightweight project that you are going to work on, and it works. Okay? Now there is another tool that is gaining traction is called Anaconda, right? So that Anaconda you will generally use when you are working with libraries like data science and things like that. You want to use Jupyter, NumPy, those type of libraries. So in those cases, it is widely used, right? So here is an example of how you activate an environment in Anaconda. So Anaconda, you can go to their website and follow download instruction and just install it, right? Then similar to VNV, what you do is you do conda create and name of the environment Python equal to version of the Python. So this is a very handy syntax. So whatever the Python version you want to use, let's say 3.5, you can just specify Python equal to 3.5, and it will create an environment based off that. Okay. Then how you do activation is you go to conda, activate my conda. That is the environment that you have created. And then if you want to install any package, let's say pandas you want to install, right? Let's say in upcoming days you want to use this libraries like pandas. So what you do is just conda install pandas, and it will install the package. And once you are done, you can just type conda deactivate, right? So basically, once you activate conda activate my conda name of your environment, anything you do after that, it will be using this conda environment, right? You do this command deactivate when you are done working with your environment. Okay? And let's say if you want to check your packages and everything that you have installed in your environment, then what you can do is just you can use pip list or conda list. So whatever environment you are using, it will be listed. So let me just show you one quick example of what I mean by that. Okay. Uh, okay. Okay. So if you see over here, I have run this command, right? Pip list. So these are all the packages which are installed in my machine, right? I have conda also installed, right? JSON patch, pip, all those pi sockets I have installed, right? Wheel. So with version number, you can see. So this will remain inside my environment, right? So in future, you may need to use it. Okay? Now, as I mentioned, we have a package manager pip in Python, right? Which is I think by default will be available to you if you type pip dash version, something like this. Yeah, so you will see that pip 23 from this location, right? And Python 3.11 that I am using. So you can check it. So over here, what pip does is pip will allow you to download other libraries. So there is a site called pypi.org. Okay, let's go over there. Okay, so here is one thing that I have used earlier, right? So whenever you go to pypi.org, you can search for any project. Let me just go to home page of that, right? Find, install, and publish Python packages, right? So you can search for any package that you want, right? Let's say I want to search package related to bar chart, right? You will see list of all the bar chart related libraries. Here is the one that I have checked earlier. So this is like speech recognition library, right? So I have pip install speech recognition. So I can just copy it, head over to my command prompt, and just paste this, and this library will be installed in my environment, right? So now I can start using it in my Python programs, right? I can look at the versions also, documentation and everything. How do you install? What are the configuration? Things like that. Right? So this is basically one stop shop for everything that is related to Python packages. Okay? So how do you use pip, right? So what you do is you do pip install and package name, as we have seen in that website command. Now if you want to install a specific package, then what you do is you can do pip install package name and equal version. So here double equal is important, right? If you want to install not latest version but any older version of the package, then you need to specify this double equal syntax. Otherwise, if you don't specify version, the latest version that is available on that repository will be downloaded and installed. Now let's suppose you want to upgrade any package, right? You have, let's say, speech recognition library installed. After a year or so, you may want to upgrade it, right? Then what you do is pip upgrade package name, and that package will be upgraded. Now, one important thing is that how do you connect this with what you have learned, right? So we have learned in import module. How do you import the module, right? So that's where you will, whenever you are now you have installed this package, then you can start using it with import uh, speech recognition, import from speech recognition, whatever the syntax that we have, and you can start using it, right? Then pip list, we have seen it. It will list the packages that are installed, right? And then if you want to remove any package, or maybe you have tried the package not working out for you, and what you can do is pip uninstall package name. Okay? So this will remove the package from the your environment. So here is an example of what I just mentioned, right? Pip install request, right? So what it will do is it will install a request library, which in Python is to call a remote API, right? So now we can just type Python to invoke the Python, then do import request. So this is how we import request. Then what we do is we do response equal to request dot get this URL, and then we you do print response dot status code. So This response library is a third party library, meaning not a part of Python directly. So you have to install it with pip install request, and then you can use get, post, delete these methods with this, and it will provide you a standard response also. So here we are printing response code. It can be 200, 500, 401, anything, right? And again, if you want to look at the list, you can do pip list. Yeah. So this is how you use pip installer. There is another concept called requirement file, which you can study it. So basically, what you will do is there will be flag when you are doing pip install. Then you can put dash r a flag to save it in a requirements file. So it will create you will create a requirements.txt file in the folder you are installing this, and the pip will make an entry of the package it has installed along with the version number. So something, it will look very similar to what the list we have seen over here, right? Something like this it will, but with equal sign and all. So when you are working with your colleague, you can just give that requirement file to your colleague, and there your colleague, what he will do is, he will do just pip install dash r and requirements dot txt. Okay, so that way all the packages that you have installed will be installed in their machine as well. Yeah. Okay, I hope that is clear. I will give you guys a minute to just review this quickly, and then we will close. Okay, all right. Okay, so with that, we end our session here. So we have essentially covered the basics of what you need to work with Python. You can practice some of this on your own, and this will be helpful to you when you attend another upcoming sessions, right? So I will share this Jupyter notebook with you guys, the new link again, right? And you can play with it. And if anyone has any questions, you can put it in a WhatsApp chat, and I will try to answer that right now. So next few minutes, we can have a Q&A session, right? If not, right, then this is all for today, and wish you all the best for tomorrow. Okay, anyone, if anyone has any questions, you can send it to me. Okay, Prantav sir, Kinjal ma'am, if anyone has any question. Okay, all right. I guess uh, that is it. Pinjal ma'am, over to you. I don't think there are any questions from the members.